Introduction, we talk about continuum mechanics, and under this continuum mechanics itself, you have to first look at the definitions of the things that will describe this continuum mechanics that is we're going to talk about in the future. But the definitions by itself, we have to make it clear, which are scalars, vectors, and tensors, and a lot of things about tensors. And in this series already we'll talk about it. But however, in this particular video, so in this video itself, I'll just try to cover up the vectors section, alright, and somewhat to briefly talk about scalar itself. And therefore, to start, the scalars are physical quantities that have magnitude and known direction, with example, distance, temperature, etc. Vectors, however, are those who have magnitude and directions, both of it, alright, velocity, force, and momentum. But I want to convey certain stuff that is somewhat a bit difference between vectors and scalars, where we are often unaware of. For it's the language itself, and by far distance and displacement, if you take a look, and speed and velocity, if you take a look, they have the same meaning, in a certain way that they are the same meaning. But if you want to take split out in terms of scalars and vectors, this distance itself is actually scalars, because distance is just only magnitude, is what distance have you moved. Displacement itself, it's the magnitude and a certain directions that is moving, alright, similar to speed and velocity, alright, it's the same thing. So I'll not go into details why are these two vectors. I assume that you already know why, but I just want to recap to you. And distance and speed are just scalars itself. Okay. Another thing for vectors itself, you have to take a look at this arrow. This arrow is often denoted by V. Alright, normally they will write this as vector, but in our context, we will try to make this as V bar, V underlined bar. Alright, so this is also called vectors. And vectors itself, as you can see, it's pointing to a certain direction, so have the directions, while this length that it is the magnitude. Alright, and so this is the magnitude itself, right? And if you were to compare with this vector, they are in the same direction, alright, just that this length itself, the magnitude, is lesser than this of the red one. Alright, so the length of the vector denotes the magnitude itself. Alright, so this is one important fact I want to share with you. And therefore, calculate the mass of the sun. Actually, I don't forget what I'm saying because I paused the video quite a while. And therefore, let me take a look. So by far, we have talked about definitions of vectors, so we're going to talk about concept of basis vectors. And therefore, what is basis vectors is, let's take a look in this picture. This is a coconut, alright, and there is the axis over here, x, y, and z, alright. So therefore, if you were to take a look in terms of 3D, this coconut is in certain basis of this base itself. So y is in terms of this coordinate. So perhaps the diameter of the coconut in this y-axis is somewhat maybe some values, I call it y1, alright. So therefore this thing is the basis, alright, the word basis, okay. And to make it more concrete enough, alright, now let's take a look at a change of basis. And I have a new basis over here, and as you can see, y is in terms of this direction now, alright, compared to this y. As you can see, the difference of angle, see, this is I'll call this x bar, I'll call this y bar, I'll call this z bar. Alright, so this is a different basis from this basis. Alright, so in some sense, this is the definitions of basis, in which if you were to do SolidWorks, sometimes you tilt it out. I'm going to talk about it, but just that this is the different basis we're going to talk about it. Alright, you can take it as local and global type of explanations. And therefore, this is by far the definitions of basis vectors. And what builds up basis vectors, this two, is that it's unique vector. If you remember unique vector, it's 1, right? It's equals to the vector itself divided by its magnitude of the vectors. Alright, I'm not going to go I'm not going to go details into what is this, just that unit vector is 1. Alright, and therefore this has a magnitude of 1, this has a magnitude of 1, and z has a magnitude of 1. and this also has a magnitude of 1, 1, and 1. Alright, therefore let me ask you, what is this thing? This is also basis vectors. Alright, this two basis vectors, alright, is actually in terms of R3. Alright, it's 3-dimensional. Alright, and this basis vectors is just R2 because 2-dimensional. So I just want to concretely make things clear for what is basis vectors. And the basis vector, its magnitude of it is in terms of unit vector, so it's 1 and 1. Alright, and therefore we often denote this stuffs not as x and y or x bar z bar. Sometimes we do, but what we do is in terms of this. Okay, so we just name this as x1, x2, and x3. Alright, in terms of x, y, and z. Alright, and therefore the unit vector, alright, or the basis vector, alright, let's put it in a different color. It's this, alright, in a green color, e1, e2, and e3. These are all unit vectors, right? Unit vectors are something with a hat, if you remember. So this is the basis vector. The green color is the basis vector. The red color ones are the directional vectors, alright? So if you tilt the basis vectors, you're going to tilt the way you analyze certain stuffs. Alright, so just to make things more clear. Just to come back to this, we have just said the concept of basis vectors. Now we're going to talk about concept of the components. Alright, the concept of the components builds on the basis vectors. Let me introduce you with this new vector. Alright, maybe I have this vector that is coming out. I don't know why, because it's very hard to draw, but anyway, so the component itself is, for example, this is one component, this is a component of a vector. So it's in certain sense, this is a vector itself. Alright, this is the vector, whatever vector that is, alright. And this is another vector, alright, or coming out towards you, alright, towards you, coming out of this picture now, towards you is also another vector, alright. So that I believe that you know what is vectors, and these vectors are just called components. Alright, they are just called components. So for example, if you were to zoom into 2D now, recap, this is the directional one. Alright, the directional sign x1, x2, and this is the basis vector e1 hat, e2 hat, and therefore the components itself is just the vector itself comprises of e1 and e2, alright, but however it's the multiple of this basis vector, as you can see, because e1 and e2 is simply, if you e1 plus e2, you are simply equals to this one, right? So this is e1 plus e2, correct? This green color thing, right? So the component itself, it's based on how many e1 and e2, alright, and therefore this is just the definitions of components. Therefore, to ensure that it really sinks into you, such that it's really into you, I have x2 and x1, alright, this is the direction that we're talking about. I put in all the values, 1, 2, 3, etc, alright. So this is what I have done, and therefore the unit vector just simply e1 hat and e2 hat, because their magnitude is equals to 1, and therefore it's 1 over here, right? It's 1. And let us have this component, alright, component or vector, alright, the component or vector called this thing, alright, it spans all the way here, alright. And therefore, if you take a look, in terms of this purple color vector that we have just drawn earlier, alright, this vector, we can actually represent them in terms of our unit hat vector, e1 and e2, alright, and therefore we have 5 unit vectors, alright, so we have 5 1 hat, alright, so 5 times the e1 hat, add up to, where's my pen, okay, add up to 3 times the e2 hat vectors, alright, write it over here, alright. Nonetheless, you can also 3 times e2 hat, and then you do this. It's somewhat the parallelogram type of stuff. And therefore, actually, I forget to write this as the vector v bottom bar, underline bar, and therefore is equals to this v bar, Alright, so this purple color vector, or I call it the component, alright, can be represented by this stuffs over here. Alright, and then therefore this 5 and this 3, alright, instead of writing the numbers, I can generalize it as v1 and v2 because it's at the axis of x1, right? So this orange color one, this really orange color one, hope you can see, it's v1, and then this, I will call this blue color one, alright, it's v2, alright, and therefore the v1 e1 hat plus v2 e2 hat is equals to our purple color v, alright, and therefore this is the somewhat components of the vector. Therefore this equation is the equation for generalized so-called components of a vector in 2D. Alright, in 2D. Components of a vector in 2D space. So if I want to represent this in a more generalized one in terms of 3D space now, so we'll just simply copy this one, alright, paste it here, and then I'll just add in a new dimension, right? So plus v3 e hat 3. So we have another component that can represent it in terms of a 3D space. So this formula over here can represent things, sorry I didn't parenthesize them properly. This thing is in the 3D space. Alright, so this thing is for 2D space, this thing is for 3D space. Alright, I hope this is pretty much very clear. If you were to take a look into this thing, it's exactly, so this whole thing over here, it's the same thing as what I've written. Where's my coconut? Shit, hold on. Alright, anyway, so it's here, concept of u1 e1 plus u2 e2 plus u3 e3. So instead of u, I write as v, so then e1 is just simply the e1 hat. So if I were to just make things more here, alright, so it's exactly the same thing, alright, so I've just shown you this is the things, alright, so it's pretty much I didn't cheat your feelings, that thing. And therefore this is just the concept of them, and just to let you know that they cannot be summed up together, alright, because they are just simply vectors. They are representing in terms of directions only, alright. So this purple color one is in terms of orange and the blue one, right? So they cannot sum out. If you want to sum out the magnitude, you're gonna use the Pythagoras theorem, alright, where is v1 square plus v2 square plus v3 square whole thing square root. You have the magnitude of the vector, alright, and therefore if you want to do summing, then this is somewhat the case of the magnitude. Alright, in terms of directions, this is directional summing of the 3D space. Alright, so I hope that this is pretty clear much of the vectors. Next video, tensors. See you there.